Dear students, today I am going to explain about perspective and issues in machine learning. In the last class, last 2-3 classes, we have discussed about what is mean by machine learning, then what are the applications of machine learning, what are the areas influencing machine learning, and how to design a learning system, and some examples we have seen in the previous class. Now we are going to discuss about perspective and issues in machine learning that we are going to see now. Okay, I think previously everyone understood about machine learning. Now we'll see perspective and issues in machine learning. First we'll see perspective in machine learning. One useful perspective on machine learning is search space. Okay, so very large space of hypothesis to determine one that best fits the observed data. That is main thing, hypothesis space. Okay, that is the main perspective in machine learning. And the prior knowledge held by the that is first one is that is hypothesis space, large space of hypothesis space, and next one is the prior knowledge of learner. The two things are main perspective in machine learning. Next is issues in machine learning. What are the issues or related to in machine learning? So when we are taking machine learning, we understood already. I told that what is meant by machine learning and how it works, all those things. So here the main things involved is data set. Okay, when you are taking data set, that depends on the attributes, number of attributes should be taken, and number of the testing and training data sets should be taken. And another thing is what type of algorithm we are using. In that algorithm itself, we are having the different classifications: supervised, unsupervised, reinforcement learning methods, method of algorithms, and so on. Okay, so these things it will come in the issues in machine learning. First we'll see what algorithms exist for learning general target function from specific training examples. Because first we are training the machine with specific training examples. From that we are moving towards a general target function. Okay, so what type of algorithms are exist for learning the general target function from the specific training examples? That is one of the issue. And another thing is, so in that algorithms covers desired function given sufficient training data. That is also another important aspect. We may be having a large volume of data and large amount of data. In that, how much data will be used for training the data and training the algorithm, and how much is used for testing. Okay, which algorithm perform best for which type of problems and representation. Problem also different. That depends on the problem and representation. It is going to vary. Algorithm method what we are going to use is going to vary. Some algorithms will give best result for some problems. Some algorithms will give worst result for another problem. Okay, so one algorithm, we can't tell the same algorithm will be used for all the type of problems. Depends on the problem, that algorithm is going to vary what we are going to use in that thing. And then how much training data is sufficient, that only already we have seen. Okay, so then next thing is when and how can prior knowledge held by the learner. That is also important. Learners should have some prior knowledge. Then it is easy for guide the process of generalizing from examples. If learner is not having any prior knowledge, it is also one of the issue in that thing. And can prior knowledge be helpful even when it is only approximately correct? Okay, so that is also one of the thing. Then the prior knowledge of a learner, that's the thing. When we are designing algorithms, the learner should have a prior knowledge in the particular problem domain as well as that area. Then what is the best strategy for choosing a useful next training example? Because first we are training the machine with some set of training example. Next we have to identify what is the strategy, best strategy we use it for choosing the next training experience. Okay, next training experience, and how does the choice of the strategy alter the complexity of the learning problem. Okay, already we know the designing the learning system, it is having the different stages. We have already we have seen that thing. So in that, how based on the thing, how the complexity of the problem of the learning problem is increasing or decreasing, so everything we should keep it in the mind. Then based on that thing, we have to select the algorithm. Okay, so that algorithm select, especially you should keep it in the mind. Algorithm we have to select. Okay, and that algorithm, when we are selecting also, that all algorithms won't shoot for all the problems. So based on the problem, that algorithm selection should be done using some best strategy. That is one of the important thing, best strategy. Then next is the training data set. In the data set, how much, suppose we are having the 1000 data sets, means in that how much will be used for training and how much data set will be used for testing the algorithm. Okay, in that thing, normally we'll use more data set for training and less data set for testing. Okay, so that way, that things we are going to see in the further modules. Okay, so these are all the issues and perspectives and issues in machine learning. Whenever you are using any algorithm for your corresponding problem solving, you should keep these things in the mind. Okay, so the next class we will see the one of the algorithm. In that algorithm, how these concepts, how we are selecting the training and testing data set, we'll see in the find as algorithm in the next class. Okay, thank you.